we'll try to prove these columns, each column. Okay, so in IPv4, we know that IPv4 is 32-bit address. Okay,
Yes.
and we use a binary and decimal numbers to represent that IPv4 address. Okay, so now it's 32-bit means it is divided into 4 octet or 4 bytes, and 1 byte equal to 8 bits. Okay, so 1 byte equal to 8 bits. So we have a 4 bytes are there. Okay, 4 bytes, or you can call as a 4 octet also, means 8 bits. Okay, so each octet has 8 bits, or each byte has a 8 bits. Okay, so like this, 8 into 4, 32 bits. So that is a 32-bit address. Now class IPv4 address is divided into 5 classes, 5 different classes, and each class has a different range, means one should not overlap with the another. Okay, that's how they have designed these classes. So class A is 0 to 127, class B is 128 to 191, class A is 192 to 223, class D is 224 to 239, and class E is 240 to 255. And they mention here multicast and experimental. So this is for experimental. Reserved addresses we cannot use. This multicast is used by the applications for multicasting. Okay, this also we cannot assign directly to the systems. And these are the unicast addresses. Again, there you will find a broadcast address for each network. So we'll try to understand all those things, and practical also will try to prove. So what is unicast, what is broadcast, and how it works. Okay, whether we can assign those IP addresses or not. Okay, so these are the classes, and we'll try to prove how to get these ranges for each class. Okay, so first we have to start with the first octet binary range, and based on these values you are getting this range. Okay, they are given here in red color 0, so that means that bit is reserved, so you are not going to change. Other 7 bits you are going to change. If you make all the bits 0, you will get 0. If you make all the bits 1, you are getting 127. Here also same thing. So these bits are fixed, 2 bits. So 6 bits you can change. If you make all these 6 bits 00, you'll get 128. If you make these bits 11, you'll get 191. So here also same, 110 is fixed, and these bits if you make 0, you'll get 192. If you make 1, you'll get 223. Okay, so here again 110. These 4 bits are fixed to get class D, and these access means if you make all these 4 bits 0, you'll get 224. If you make these bits 1, you'll get 239. And same thing class C, these 4 bits 1 1. If you make all these 4 bits 0, 240. If you make 1, you'll get a 255. 0 to 255. So each octet, this is the first octet. So based on that, then you'll get these ranges for network ID and host ID, subnet mask. So that is to find what is IP network ID of the given IP address, then how many hosts per network you can connect, and the number of networks you will get for each class. So these tables give the information about that. So we'll try to understand each and every point from this table, and we'll try to prove that. Okay, that's what we are going to do right now. Okay, now we'll go with this first octet. Oh, sorry. Okay, so IPv4 addressing. You know that it is 32 bits address. Okay, so we use 32 bits address, use binary numbers or decimal numbers, IP address representation. 32 bit means, so to represent IP address, we divide the address into 4 bytes, or you can say octets. Okay, so each byte or each octet it has 8 bits. Okay, so then we can say here 4 octets into 8 bits equal to 32 bits. Yes, is that right? That is a 32 bit. Okay, so
Yes.
now, okay, in each octet, each octet 8 bits. Okay, that means maximum numbers we get equal to 2 to the power of 8 equal to 256. Okay, 256. The range is 0 to 255. Okay, for each octet. So totally you are getting 256 numbers. That means including 0 and 255 you will get a 256. Means each octet, in each octet you can use the numbers either from 0 to 255, any number you can use. Other beyond this you cannot use any numbers in that octet. Is that clear?
Yes, sir.
Well, this one, Viresh.
Sir.
Yeah.
Yeah,
Okay.
yeah.
So now here in this table they are given this. Okay, first octet. We'll go with the first octet. Okay. So we have a first octet, like we'll consider like this. First octet dot second octet dot third octet dot fourth octet. Fine. Now first octet. In the first octet they are telling like this for class A. Now we'll go with the classes. Class A. Okay, for each class we'll calculate all the things. So class A octet, first octet, reserve bits. So that is, so 0 x x 4. Yes, it's correct. 8 are there. These are 4 and these are 4. Yes. Okay. So now what we'll do? We'll make x value as 0 and 1 to get the range for class A address. Fine. So we'll make 0, all x value 0, x equal to 0. Okay, we'll take then 0 0 4 5 6 7 8. What is the value we'll get? This is in a binary, 0 will get. Yes, converting from binary to decimal. Now if I make here 0 is reserved, we cannot change. Other x values I'll change to 1 1. So what value will get now? So 1, huh? No, convert. No, this is in a binary. You have to convert into decimal. I will do that. You have to convert from binary to decimal. Convert from binary to decimal. This is also same. So what value you are getting? 1248. You write in your book 1248. So that is means this is no simple. 0 1 1. Sorry, 1 1 1 1 1. How much this? 1 2 3 4 5 6 7 8. Huh?
255.
No, this first bit is 0. No.
Yes, sir.
So yeah. So
Sorry,
this
sorry.
is
Yes,
okay.
sir.
So you have to come in reverse way. Okay. So
127.
this is 1. This is bit position is 2. This is 4. This is 8. This is 16. This is 32. This is 64. And this is 128. 8. So now if you do this, so if you do the multiplication, so how much you will get? That is 0. No, the same thing. 0 into 128, 0. Yes or no?
Yes,
plus
sir.
1 into 64, 64,
30.
plus 1 into 32, 32, plus 1 into 16, 16, plus 1 into 8, 8, plus 1 into 4, 4, plus 1 into 2 is 2, plus 1 into 1 is 1. How much you'll get?
239.
127, sir.
127. Yes. So this is what we have done. And you know how to convert. This is a procedure. Yes or no?
Yes, sir.
1
Yes, sir.
2 to the power of 0, 2 to the power of 1, 2 to the power of 2, like this. So directly I have written numbers 1, 2, 4, 8, 16, 32, 64, 128, like this. Okay. Please remember this table. Simple.
Okay, sir.
Okay. So then whatever the binary value is there for each octet, so you can just write like this in your book and convert into the value like this. Okay. So now the range for class A 0 to 127. Now you got the range. When you
Yes, sir.
make all the x values 0, you are getting 0. When you make all the x values 1, you are getting a value 127. Yes or no?
Yes, sir.
Yes.
Yes, sir.
Now x equal to 1, you are getting a value 127. So the range for class A is 0 to 127. So that's what they are given here, 0 to 127. Is clear?
Yes, sir.
Yes.
Yeah. Now we'll go with the IP range. For each one, we'll do row wise. Okay, so then we'll go for a next class B, class C, class D, like this. Now, or you want me to finish this column and then you go for this column like this? Tell me how you want. You want row wise or column wise?
Uh,
Column.
wise.
Huh?
Sir,
What? Anything is fine?
anything is
Okay.
not a problem.
Okay. So we'll go with this one. So column wise, so we'll finish one column. So it will be easy to calculate. Same procedure you have to apply.
Okay.
Okay. So now the same thing, class A is done. So class B. Okay. So class B. Class B. I will copy this. Same. Control C. Control V. And here I will change to the class B. The first octet reserved bits in class B is what? 10. Yes. So
Yes,
this
sir.
is the standard they are following. 10. Okay. So now here I will make here 10. The first octet is 10. Yes. Is that right?
Yes, sir.
Okay. So we'll make here. We will make x value as 0 and 1 to get the range for class B addresses. Same procedure. X equal to 0. Here it is 1, 0. Yes or no? So I am
Yes.
making all the x zeros here. Now instead of 7, I have only 6 x. Yes or no? Yes. Only I can make the changes to this one. So convert from binary to decimal. So what value will get now here for this one?
We'll check it, sir. 128, sir.
128. Yeah. So if you apply this one, no, same. All bits are 0. Only this bit is 1. 1 into 128, you'll get 128. Yes?
Yes, sir.
Yeah. So now here, 1 minute. 1 to get the range. So when you take x value 0, we are getting 0. And when you take x value 1, so we are getting the value 127 from converting from binary to decimal. Okay. So and the range for class A is 0 to 127. Now for class B, we are getting the range. So we are calculating the same procedure. First octet reserved bits. It is 10 for class B. Okay. We'll make x value as 0 and 1 to get the range for class B address. So when we take x equal to 0, we are making all the x values here. Okay, so these bit values making 0 and converting from binary to decimal, we are getting 128. That's the starting range for class B. And when you take a value, x value 1, so this should be 10. Yeah. So 10. Okay, so and here I'll change. This is 1 and this is 0. Okay, so now if we convert this value, okay, so binary value to decimal, what value will get?
191, sir.
191, sir.
191. Okay, so here it is 1 as 128. It is 0. Yes, 64 is not there. 0 and all are there. Yes, so we'll get a 191. Okay, so this is the range for class B. So the range for class B is 128 to 191. 128 to 191. So this is, we got the class B range according to this table, 128 to 191. Now we'll go for a class C. So the reserved bits in the first octet for class is 110 and other bits are either you take 0 and 1 to get this range. Okay, so 192 to 223 we should get for class C. So now same thing, just copy this entire thing. for class C. So it is 110. Okay? 110. Is that right?
Yes, sir.
110.
Yes, sir.
And then same x0, it is 110. What value will get if you convert this binary to decimal?
96, sir.
Huh?
96.
This one 110. See, we check this. 128 plus 64.
192, sir.
192. Yes, 192 will get. And now x we are taking here. This is 110. Okay, so now we convert because we made these 5 bits x. Okay, so 0 here and got the value 192, and here I made x values 11. So I'm getting the value. What value will get here if you make 110? Convert this into the binary. Sorry, convert this binary to decimal. So 128, 1 into 64, 64 plus 0 into 32. Here it is 0. And plus 1 into 16, 16 plus 1 into 8, 8, 4, 2, 1. So once you convert this and you add all these values, what value will get here?
223.
2,
23.
yes, so means class B range is 192. Yes,
Yes, sir.
so can you calculate for a class D?
Yes, sir.
Yeah, follow the same procedure and tell me.
Sir, for class D,
Ah,
uh,
what is the first octet value?
yes, sir. 1110, no, sir.
Yeah, 1110. Okay. Okay, so it's 1210. So okay, what value will get for class
Sir,
D?
224.
224. Okay, and if you make all bits 1 1, here 1, it's 1, and here it is 0. Yeah, 64 plus 32, it is 0. Yes, 0 into 16, 0. What is the value will get?
224.
239.
Viresh. Yeah, 239. Viresh, are you calculating in the same way?
Yes, sir.
So then how much value you are getting here? For when you
Sir.
make all x values 1 1, this is these are reserve bits. Okay, so only x value you have to change from 0 to 1. Here you have taken all x values 0, you got the 224. Now you have to take x value 1, and here you should get 2. Let's calculate once again and check
Yes,
it
sir.
out. Are you getting 239?
Yes, sir.
It's correct. Okay.
Yes, sir. Correct.
Okay, so means class D is 224 to 239. Yes, sir. Class D is 224 to 239. This is a class D. So this is class. Okay, so now for class E, calculate for class E.
What is the first octet, sir? Class E.
Class E. Okay, so the first octet value is
1111.
yeah. Okay, 4 ones MSB bits, then XXX. We can make either X value 0 and 1. And share this file. It's I have said no link, so you can take this file.
Sir, 240.
240, sir.
240. Okay. 1 0 240 and this
255.
255. Okay. Okay, so 240 class E address is 242 255. Yes.
Yes, sir.
So we have proved the first column. Okay, so that means so first we have to consider first octet binaries for each class, first octet value. So then accordingly you change the values. Once you take x value 0, then you'll get first range for that class A. When you make these x values 1, we'll get the range last network ID for that. So it means the range in the first octet value range, okay, for that class. So for class A 0 to 127, class B 120 to 191, class C 192 to 223, class D is 224 to 239, and class E is 240 to 255. Okay, so now before going for this IP range, okay, so first we'll go with the address format. Okay, they are not mentioned in this one. We'll go with the address format. We'll get the subnet mask for each class, then we'll go with these ranges. Okay, so then we'll tell after this we'll go for a number of hosts per network ID and the number of networks we'll get for each class. Okay, so that will calculate. Now here next one we'll go with the address format for each class. Okay, each class. So for class A, okay, for class A, the address format is network, host, host, and host. Okay, so class A. This tells that you consider each IP address has two parts. One is network ID, another one is host ID. If you want to make two systems in the same network, their network ID should be same with a different host ID. So each system has same network ID, but with a different unique host ID. You cannot assign the same host ID, same network ID to the multiple systems. You have to assign a different network ID should be same, host ID you have to change. Like suppose in class we have seen that 0 to 127 is a range for network IDs. If I give one dot, okay, so why it is 0 we cannot use, we'll see that next later when we test that. Okay, so 1 dot 0 dot 0 dot 1, so that is a one IP address. Another one is 1 dot 0 dot 0 dot 2, that's a another IP address. In these both the network ID is same, the host ID is different, so then I can say both are valid IP addresses and belongs to the same network. That's how we consider and assign the IP addresses for the system. So now first we will understand what is this address format. So address format, this always tells that what is the network ID of the given IP address. Okay, so that you can calculate. So the for class A, the address format is network host host host, means the first octet represent the network ID and other three octets represent the host ID. So okay, so that means this is the network ID, that is first octet, then plus host ID. Okay, so this is a second octet, second, third, and a fourth octet together considered as a host ID. So that gives you IP address. Okay, so that means each IP address has two IDs, network ID and the host ID. Okay, so if I'll write that one also, if you want to make, we'll test with the packet tracer also, make two systems in the same network, then they must have same network ID with different host ID. Okay, so then only they will communicate. So this is the network host. Okay, so now suppose consider this. Suppose if I take 10 dot 10 is belongs to the which class A. So first octet value, it belongs to which class A or class B? 10 number. If I write here 10 dot 0 dot 0 dot 1
Class
something,
Class
you
A,
have to,
sir.
because this value you have to check 10. If I write here 128 120 130 and write like this, it belongs to which class?
Class B.
Class
B.
B. Okay, so if I write here 192, it's
C.
Class C.
class C. Okay, so based on the first octet value you can decide whether the given IP belongs to class A, class B, or a class C. Okay, so now here 10 dot, if I write here 10.0.0.1, this is the network ID and this is a host ID. Okay, so now I'll take here next 10.0.0.2. Okay, so these two addresses, these IP addresses have same network ID or different network ID?
Same network,
And what about host ID?
different host ID.
Different host ID. Okay, suppose if I give here 10.200.1.6, now is it in the same network, third IP address?
No, sir.
It is in the same.
It
Yes,
only,
sir. Same, sir.
you have to just check the first octet value. Yes,
Okay,
sir.
sir.
First octet value. Okay, so this IP address is in the same network because the network ID is same for all these three, so they are in the same network with a different host ID. You can take each octet 0 to 255 any value. Yes or no? We have seen in the beginning itself. See here. Yes, for each octet. So 2 to the power of 8 we have done 256. The range is 0 to 255. Means for each octet you can take a value from 0 to 255. So here for each this one we will take 0 to 255. Okay, that's how it works. So before that, so before discussing that, we'll just concentrate on this address format. So class A, this is address format, network, host. Okay, so this is a network ID, this is a host ID. Now here, so we'll calculate now the subnet mask also. Okay, here is they are written here 255.0.0.0 0.0.0. When you get the address format, you can calculate the subnet mask also for each class, and I'll write here subnet mask also. Okay, so class A, it is a address format, and the subnet mask, how you can calculate, you make all the network bits 1 1. Okay, just make all the network bits in the network ID 1 to get the subnet mask for each class. Make all the bits to 1 in the network ID. Okay, so now what will the subnet mask for this? Hello. Okay, so you have to make here first octet all 1 1 4 5 6 7 8, and then host ID you make all 0 0 4 5 6 7 8. So this is now, if you convert this into the decimal, convert into decimal. Okay, so what is the value you'll get?
255.0.0.0.
55.0.0.0. So this is we call as a subnet mask for class A. Okay, this is the subnet mask for class A. So first we'll calculate the address format, then we calculate the subnet mask, then we'll go for why the subnet mask is required. Okay, how the system understand the given network ID of the given IP address, because it does the logical AND operation between the given IP address and subnet mask to get the network ID. Based on that, it can recognize whether the destination system is in the same network or different network ID when you ping. Okay, so it calculates the network ID with help of this subnet mask. First, we will try to understand the subnet address format and subnet mask. Okay, so then we'll go for other things. For this one we'll go, then we'll go for this column, then we'll go for this. Now I'm concentrating on a subnet mask under address format. Here address format is not there, I'm writing there, and based on that we are getting the subnet mask. Is that clear till this point, Virish?
Yes, sir.
Yeah, so now for class A is done. Okay, we'll go with the class B. Okay, so class B, copy this, class B. Okay, for class B the address format is this one, NNHH. So means network ID is first octet and second octet, and host ID is third and the fourth octet. Okay, so it's the same procedure. So here means you want to make two systems in the same network, their network ID should be same. For class B, you have to consider 2 octet value as a network ID, 2 octet value as a network ID. Now to get the subnet mask for each class, make all the bits to 1 in the network ID. So now here I have to make all these are 1 1 4 5 6 7 8. Okay, now convert into decimal. What value will get now?
255.255.0.0.
Yes. Okay, so this is the subnet mask for class B. Okay, so this is they are given the subnet mask for class B. Okay, so now we'll calculate for a class C. For class C, the address format is 3 octets represent the network ID and 1 octet represent the host ID. First octet, second octet, and third. Host ID is only this fourth octet. So same, everything is same here. So here I have to make now all 1 1. Yes.
Yes, sir.
Now what value will get here?
255.
Okay, this is for a class C. Okay, so for class D there is no address format. Okay, so anything you start with the 224 first octet value to till 239, it will be considered as a class D and it's a multicast address. So there is no address format for this. Okay, so that's the reason they are not given the subnet mask for this class D. Okay, and class C is reserved. So there is for these all. Okay, class A, B, and C, you can call it the unicast addresses, and for each network we'll get a broadcast IP also. So that also we'll discuss later. So means in the communication modes we have unicast, multicast, and a broadcast. So that we'll understand now. Then we'll go for next, that is IP address range. Okay. So modes IPv4. So in IPv6 we have unicast, multicast, and anycast. There is no broadcast. We'll discuss that one later when you go with the IPv6. So here we have unicast. Unicast means 1 to 1. Okay, suppose I'm communicating with only Karthik. Okay, that is, you can say unicast 1 to 1. Okay, so that is 1 to 1. Then multicast, multicast 1 to many, 1 to many. Okay, in this session I'm communicating with the Karthik and Viresh, not with the Prashant. Then you can say multicast 1 to many. You have hundreds are there, but you are not communicating with all hundreds. You're communicating only few, maybe 50, 60, or 80, 90, not all. Okay, so that is a multicast 1 to many. Broadcast, broadcast 1 to all. Okay, so this is these communication modes we use in IPv4: unicast, multicast, and then broadcast. So unicast, you can say class A, B, and C addresses. Okay, and multicast, we say class D address, and broadcast each class, each network ID in class A, B, and C will have broadcast IP. Okay, so ID you can say. Okay, so that we will see each network ID when you go to 1 or 2, each one. If you make all the host bits in the host ID equal to 1, then you will get the broadcast IP for that network ID. Even if you go for subnetting, you can apply the same procedure. So okay, so that we'll see later. So first we have to understand unicast, multicast, and broadcast. So unicast 1 to 1, class A, B, and C, we use those addresses for unicast communication. Multicast, we use 1 to many, that is class D address, and broadcast 1 to all. So each network ID in class A, B, and C will have broadcast IDs. That we'll see when you calculate. So I hope this column or this is completed. So have you understood this about subnet mask, how we are getting this subnet mask? Based on the address format. Class A, network, host, host, host. So you have to get the subnet mask. You are making all the bits in the network are equal to 1. So you are getting the subnet mask. To get the class B subnet mask, the address format for class B is network, network, host, host. So you are getting 255.255.0.0. Then for class C, network, 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 host. Okay, so you are getting this subnet mask for a class C. So now we'll go with the this first we will calculate the number of hosts and the number of networks, then we'll go for an IP range. Okay, so here we can test with the packet tracer also, why it is valid, why it's not valid, how you are making two systems in the same network, different network. That this column will go at the last. So before that, we'll calculate now host per network ID. Host per network ID means if you go with the 1 or 2 network ID in a class A, how many hosts you can calculate for that network. How many hosts you can calculate for that network means that with the same network ID, how many systems you can make in that network, means with the same network ID, how many systems you can connect to that network. So that's the meaning of that here. number of hosts per network ID. So we reached, and Karthik, is it clear till this point? Do you have any question on this?
No, sir.
No, sir.
Okay, yeah, okay. So now next one we'll go with the host per network ID. For each class we'll calculate hosts per network ID. Okay, host per network ID. So here class A, we'll go with the class A. Okay, so we know that class A, the address format and the reserved bits also we know. Okay, in class A, the address format is network host, and the reserved bit is 0. Yes, reserved bit is 0.
Yes, sir.
Okay, host per before that we'll go with the number of networks, then we'll go for the host per network. So first, sorry, number of networks, then we'll go for the later number of hosts per network, number of networks. Which class? So class A. Okay, so number of networks they have given here 2 to the power of 7. Why they have taken 2 to the power of 7? Because the address format for class A is, what is that? Network host. Yes or no? Only the first octet. Yes, and the first octet, the reserved bit is 1. Reserved bit is 1, and the value of that bit is 0. Already we have seen that. Yes or no here?
Yes,
This
sir.
one, yeah. So this is a
Yes.
first octet, and this first octet tells the network ID, and here one bit is reserved 0, that value, and other bits 7 bits are there. Means you are able to change the value of only those 7 bits. Either you make 0 and 1. So means how many valid bits are there? Means bits you can change here in the first octet. That means your 0, x 4 5 6 7 8. Yes, over 8, yeah, 4 4. Okay, so it means you can change how many bits you can change in the first octet.
7.
7 bits.
7 bit. And what is the network ID? Only the first octet tells the network ID for class A.
Yes, sir.
Yes, then how many bits you will get a network bits?
So 1 bit for network and 7 bit for hosts.
No, only this is a network ID. First octet is entire thing is network
Okay.
ID. So in that,
Then-
so the first octet is first bit, MSC bit is 0 because it is reserved according to standards. We are not going to change this. Based on this only we have got this range 0 to 127. Okay, so here only 7 bits we can change here. So we have calculated. If you make all these 7 bits 0, we got the value 0. If you make all these 7 bits 1, we got the value 127, and that is the range we got for a class A 0 to 127. Is that true?
Yes,
Yes,
sir.
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 Yeah. So now we want to get the number of networks. So they have taken 2 to the power of 7. They have not taken 2 to the power of 8. Even the network ID is there. Okay, first octet 8 bits are there, but out of 8 bits, how many bits you can change? Value can change because only 7 you can change. You cannot change all 8 because this is reserved bit, first bit. Okay, so the number of network bits you can change. I'll write like this so you'll understand. You can change equal to 7. Number of network bits you can change in the first octet. First octet equal to 7. Okay, so now the total number of networks, the total number of networks equal to 2 to the power of caret I'm showing. So 7 equal to how much you'll get?
128.
128. Okay, means that is 0 to 127. Yes or no? Network IDs you are getting. That's the reason you are getting the network ID 0 to 127. Okay, so 127. The range is 0 to 127. But here I want to calculate the total number of valid network IDs. The total number of valid network IDs equal to 128 minus 2 equal to 126. Why this minus 2? If I take this 0, network ID, the system will not accept. And if I 127, it's a loop back. Okay, I cannot use. So that means 0 network ID is invalid. Network ID, so we cannot assign for the system. And 127 network ID is loop back IP address. That means it is a reserved IP, okay, address. So we cannot assign for the system. So how to check whether the system accept these IP addresses or not? Okay, to test that one. So is that clear till this point?
Yes, sir.
Sir.
Okay, we have done that. We know that address format already. We have considered that, and also we know the first octet reserved bits in the class A. This is the 1. Okay, 0, that is 1 bit is reserved. So based on that, we calculate number of network bits you can change. In the first octet is 7. Okay, only these 7 bits you can change. That's the reason I have taken 7. Then I calculated the total number of networks equal to 2 to the power 7, 120. The range 0 to 127. The total number of valid network IDs equal to 128. These are total number of network IDs. I'm getting 128. But I want to calculate the valid network IDs, which we can assign for the systems. Okay, so 128 minus 2 I'm making, that is means 0 and 127. 0 network ID, the system cannot accept, we cannot assign that one. 127, it's a loopback, it is a result. Mainly we use to test the network. Suppose if I go to the command prompt and type here ping any IP address starting with 127, you can give the host ID anything. Okay, so sorry, mistake. Still it is taking. Okay, see that system is taking. Okay, I'm getting reply. That means your network adapter is functioning. Mainly in the troubleshooting, the networking issues, so we use this IP, okay, to test the network adapter. So ping to this loopback, you are getting reply means your network adapter is functioning properly. You can take any value in the host at 127.10.10.100. Okay, you are getting reply. So that means your network adapter is functioning properly. This main is network ID. You can take any host ID, okay, to test that. So that is the loopback we call. Now here the system will accept or not. To check that, I'll go to the Cisco packet tracer. You can also open. You have installed, no, both of you, Cisco
Yes.
packet tracer. Yeah.
Yes, sir.
Okay. So once you open, click on here end devices, and take the PC, drag and drop. Okay, take one more PC. Then click on here network devices, switch, take 29601 switch, and this is the connections. Plus first you see here, then you can connect. Okay, so take
Sir,
two pieces. Yeah,
how to understand the specification of switch like 296024TT like that?
and you take one switch 2960.
No, sir. I mean, how to understand the specification, like what that.
You have to go through that. So you have to download the manual, then you can go through details about the switch series. Okay, so PC0, you take two PCs, PC0, PC1, and the switch 2960, and then you click on this connections here. So whenever you connect from PC to switch, you have to use a here types of cables. You can copper straight through cable, and here copper crossover cable. Okay, so this straight through cable mainly to connect dissimilar devices. You want to connect from PC to switch or switch to routers, then we have to use a straight through cable. You want to connect from PC to PC, switch to switch, or switch to hub, then we have to use a crossover cable. Okay, so they follow the standard 563 563 and 563B. Is that right? Cabling standard. Okay, so based on that you can make it a crossover and a straight through 1 to 3, 2 to 6, and then 3 to 1. Okay, that it will change. We'll discuss that one when you go through the cables and connectors. Okay, that how to make the same cable. Okay, yeah, straight through and a crossover cable by crimping in both the sides. Okay, with that RJ45 jack, that we'll discuss later. Now we have to understand straight through to connect dissimilar devices. PC to switch you want to connect straight through. Okay, switch to router you want to connect straight through cable. Okay, so click on this straight through PC 0, fast Ethernet 0, switch fast Ethernet 0 bar 1. Okay, fast Ethernet means 100 Mbps it supports. Okay, some you can see there gigabit Ethernet is also there. Gigabit Ethernet port means if you connect to that port, it supports 1 Gbps. That's the meaning of that. In real time also it is like that. When you see the physical switches, if it is fast Ethernet, it supports 100 Mbps through that port. If it is gigabit Ethernet port, then it supports 1 Gbps. Okay, so here straight through fast Ethernet 0, fast Ethernet 0/2. Okay, so now here PC 0 is there. Now I want to assign the IP address for this one. Okay, I'll go to the desktop. Have you done this connection like this?
No, sir.
No, sir.
So you want me to wait or shall I go ahead?
Yeah, please make it, sir.
Okay.
You can go ahead, sir.
Go
Okay.
ahead, sir.
First we will understand, then we'll make it.
Okay. So so PC 0. Okay, so what you have to do when you click on this PC 0, click on this desktop, and then you can go with the IP configuration. And here static is there, then DHCP is there. Okay, static, you can assign the IP address in two way for each system, either manually or dynamically. Manually you want to assign, you have to select static, and dynamically you want to assign, you can select DHCP. And if the DHCP server is there in your network, it will assign the IP address. That also we are going to see later. Okay, now we want to test whether it will accept that network ID with the 0 or not. 0.0.0.1 I will give. Okay, so this means, is this given IP has a valid network ID and valid host ID? I can say the given IP is valid only when it has a valid network ID and a valid host ID. What is the network ID of this IP address here?
0,
0. And what is the host ID?
1,
1 or 0.0.1?
0,
0.1.
Because you have to consider 3 octet, no, as a host ID and 1 octet as a network ID. So this is 1. Okay, see there. This is an invalid IP address because system will not accept the IP address starting with the 0 network ID.
Okay.
Getting my point? If I remove this, if I give here 1.0.0.1, now it is accepting. Yes, so that means, so 0 it will not accept, 1 it can accept. So now I can change this up to 126.0.0.1 I can take, and see it is accepting. Now I will assign here 127 and check 127.0.0.1. Again it is showing that this is an invalid IP address, means it is not accepting a 0 network ID and 127. Yes or no? Accept those two, it is accepting 1 to 126. You give any number in the first octet, and it is automatically considering the subnet mask. Yes,
Yes, sir.
based on the network ID, say 255, because it is taking the value, it is considering this first octet value. The first octet value is in between 1 and 126 from class A, so automatically it is taking the subnet mask network ID and host ID, this like this network host. So it is making all the host bits 00 to get the subnet mask. Yes, clear? So
Yes.
okay, so that's the reason I made here -2. So 0 we cannot assign for the system, it will not accept, and 127 as a result we cannot assign. So if I want to calculate the total number of valid network IDs in the class A, that is 126. 128 -2, that is 126. This is clear?
Yes, sir.
Yes, sir.
So okay, so they are not given the number. If you calculate, they are just given 2 to the power of 7. We calculated, we got 128, but again out of 128 how many are valid? So that is, it is 126 IDs are valid, that is 1 to 126. Okay, remember 1 to 126. Okay, so now we'll go with the class B. Okay, class B networks in this. Okay, so address format for class B. What is address format for class B?
Network host.
Host. Yes, and in the first octet the reserved bit is, how many reserved bits are there in first octet for class B?
2.
10. Yes,
Yes, sir.
bit. Two value of that is 10. Yeah,
Yes, sir.
so here it is 10. Yes or no?
Yes, sir.
The number of network bits you can change in the first octet is 7, and here you have to write again the number of network bits and change in the
First.
second octet. Yes or no? Because see, what is the network ID?
Yes, network, host. So
Yes or no? So
yes,
two
yes.
octets we have to consider as a network ID for a class B. Yes or no? So
Okay,
that means you have to calculate the network bits in the both the octet. So in the first octet, out of 8, 2 bits are reserved. So it should be 6 here. Okay, first octet 6. And the number of network bits you can change in the second octet, all 8 bits. Yes, you can take any value here. So 6 plus 8, the total number of network bits equal to, first we'll do that, network bits equal to 6 plus 8
8,
equal to 14.
14.
Then the total number of
Network,
networks equal to 2 to the power of 14.
14.
So what value will get? ALC 2 XY 14. You get 16,384. 16,384. The range is okay. So already you know that. So range for class B is, what is the range for class B is 120 to
191.
191. So means how it goes is 128 to 191. So this means when you write here, it will be like this. Okay, so we'll write here 128.0.0.1. Okay, so we'll write 128. You can make this post bits I will 0. Just network ID will consider 128.1.0.0. This network ID is 128.2.0.0. So like this, if you write like this, last you will go to the 128.255.0.0. Then once it reaches 255, you will change 129.0.0.0. Then it will go like this. If you at the end, you will get to 191.255.0.0. So if you calculate all these, if you write continuously like this, you will get a total number of network IDs 16,384. That is the meaning of this total number of network, because this is one network ID, this is another network ID, this is another. So like this, you can go up to dot 2, 3, 4 for 128, 255 will get. Then next 129 network ID will change 0 again 255, 190, like this up to this. For each network ID you are changing 191 till this 0 to 255. If you calculate, you will get a 16,384 network IDs. That's the meaning. Even if you real time, if you sit and do, you'll get a 16,384 network IDs in a class B. Yes, is that clear? Do you have any question on this part? Karthik, Viresh. If you are not understanding, please let me know which part you are not able to understand. Have you got this class B?
This one first octet is equal to 6. That one is not understand.
Okay, see there. The first octet is 6, you know, because what is the address format for this one? First octet you checked here, class B. Class B, okay, here 8 bits are there. Out of 8 bits, 2 bits are reserved. Yes or no? 2
Yes,
bits
sir.
are reserved. Only you can change only 6 bits. So that's the reason we have taken a 6 bits here. The number of network bits you can change. See there, this statement you read. The number of network bits you can change in the first octet 6, because 2 bits are reserved here. Yes? You want me to write that? Huh? 2 bits are reserved. Yes. Next question is, Viresh, why it is 8?
Second octet.
Second octet, see what is the address format for class B? Network, host. And what we are going to calculate, number of network ID. Before calculating total number of networks, we have to calculate the number of network bits. So to know the network bits, these, the first octet bits also network bits, the second octet bits also network bits. Yes or no? Do you agree?
Yes, sir.
Yes. Okay. So in the first octet, we got 6 bits because we can change only the 6 bits. Out of 8, 2 bits are reserved. In the second octet, no reserved bits are there. I can use all the 8 bits. I can change all the 8 bits.
Yes, sir.
So that's the reason I have taken the total number of network bits you can change in the second octet is 8. Now you have to add, because the address format for class B is network, host, and these two first octet represent the network ID. So the total number of network bits equal to, from the first octet 6 and from the second octet 8. So total we are getting a 14 network bits. Is that clear?
Clear, sir.
And now the total number of networks equal to the power of 14, will get a 16,384. And the range is this is you are getting like this 128.0, because we know that what is the range for 120 to 191 first octet value. First octet 128, second octet we can make 0, because this is also part of the network ID. You can take 0, then 1, 2 up to 255, then 129, 0 up to 255, 130.0 up to 255, like this 191.0 to 255. If you calculate all these network IDs, each one, you get total how many number of network IDs you'll get? 16,384. That's a meaning of this.
Sir, isn't there a loopback ID for this class?
No, loop back is fixed. No, 127. There is no loop back. All network IDs are valid here. No -2.
Okay, sir.
Okay, so all network IDs are valid. There is one comes, that is APIPA, automatic private IP address. It starts with the 169.254. What is that? We'll discuss later. Go with this dynamic IP addressing. Okay, so but all network IDs are valid in a class B. There is no -2. Okay, like we have done -2 in a class A only because the 0 was network ID was invalid and 127 was a loopback. That's the reason we have done -2. Here in class B, we need not to make -2 for the total number of networks.
Okay.
Okay, so okay, we'll stop to now. And class C you can calculate. I'll share this file with you. Okay, you can calculate
Okay,
for a
sir.
class C, same for class for address format for class C is 0 is n network host, and calculate, follow the same procedure, get the total number of this. We should get 27. Okay, today got 27 total number of network, because see that it's a network. So 3 octets. In the first octet, 3 bits are resolved. Means only you can use a 5 bits to, yes or no, you can change the 5 bits. 5 plus 8 plus 8. How much you will get? 5 plus 8 plus 8.
21.
That's what they have written, 2 to the power of 21. Okay, so calculate and then we'll see tomorrow. Fine.
Yes, sir.